Well, it's a bit windy, so I don't know if we're going to be able to hear any of this anyway.
I know. It's picked up suddenly.
But if you can hear us over the wind, and we do end up using this footage, in this video, we'll be continuing our journey into the Stonehenge Bluestone Debate, taking a much closer look at the glacial transport theory and assessing the recent claims regarding a Scottish provenance for the altar stone. To help with this, we have a channel first, and something we'd like to do a lot more of in the future, an interview with an expert in the field.
I'm a geographer by training, with glacial geomorphology being my special field.
So we were delighted to sit down with Brian John, who agreed to go on camera and answer all of our questions, many of which are directly from your comments on the last video. Now, this is a part 2, and if you've seen the first one, that's perfect. But if not, you should be fine watching this one first. Just make sure you watch the other one later, yeah? Last time, we looked at how the debate has evolved and commented on the general tendency to dismiss glacial transport, going on to question the claims of bluestone quarries and a proto-Stonehenge in the Welsh Hills. And with lots of positive feedback on that video, and comments encouraging a deep dive, and questions regarding glaciers and glacial erratics, we started planning the next video. But then, only 10 days after we've uploaded that video, a new jaw-dropping study was published, claiming once again to be rewriting the history books, with a Scottish provenance for the altar stone and an even more extraordinary story of human effort and accomplishment in Neolithic times. And the comments began to point out that we needed to do an update. Once again, glacial transport had been dismissed, but this time the glacial modelling seemed to agree with that. Compared with glacial transport from the Preseli area to Stonehenge, a route from the Orcadian Basin appeared to be quite unlikely. So what does this mean for the Bluestone debate? And if there isn't enough evidence to suggest that a glacier could have transported the 6-ton block of old red sandstone from the northeast of Scotland to anywhere substantially closer to Stonehenge, can this only be explained by human transport? Or is there some other possibility that hasn't been addressed yet in this study? Welcome back to our channel, Coral Jacks, where we visit ancient sites and explore the history and folklore that surround them. Your support has been really helping our tiny channel this month, and we've had more views and subscribers than in our first year. So thank you all so much for watching, liking, and getting involved in the comments. As soon as this video's up, we'll be recording a thank you / channel update, where we'll answer some of your non-history related questions, give a bit of behind the scenes of our rather basic operation, and let you know our plans for the future. But for now, let's get back to the topic at hand. With more comments asking for an update on the altar stone appearing every day on our newest video, and a daunting pile of data to work through, we decided to do some healthy procrastination and popped out to take a look at the Bluestone Museum. Hoping to meet the proprietor for the first time, we thought maybe we could be a bit cheeky and save ourselves a bit of legwork by running through a few ideas with him. A warm, friendly introduction was followed by a fast-paced discussion covering the main points of the debate and anything else that jostled for attention. Unfamiliar terminology and processes were explained with an ease and fluency that can only come from years of immersion in a topic. So we asked if we could come back with a list of questions, set up our rather basic kit, and record an interview. Not only did he agree to sit down on camera with us, he was happy to answer all of your questions from the last video, and he also shared his somewhat surprising thoughts on the altar stone.
It would be very difficult to imagine a situation in which a big erratic like the altar stone could have been carried by ice all the way to Stonehenge. So I would agree with the authors in that particular respect. I think they've been very foolish to leap to this wild conclusion.
Now, for those of you who have no idea who Brian John is, and only a rough idea about glacial transport, don't worry, we'll cover all the introductions. But if you're already acquainted, or only clicked on the video for an update on the altar stone, chapters are down below. So, could you start off by introducing yourself and telling us a bit about your professional background.
My name's Brian John. I'm a geographer by training, with glacial geomorphology being my special field. From grammar school, I got a place at Jesus College, Oxford, and studied geography there, and stayed on, played far too much rugby, but anyway, did some work, and stayed on to do my doctorate afterwards, also at Jesus College, and concentrating on the Ice Age in Pembrokeshire. And while I was in Oxford, I actually spent a lot of time on expeditions. Went on one expedition to Iceland, another one to Greenland, East Greenland, and then did a lot of work in Norway as well, and then back to Iceland again. And after I'd finished my doctorate working on the Ice Age in this area, I got a job with the British Antarctic Survey. The thing that happened afterwards, which I found quite gratifying, was that I got a letter out of the blue from the Antarctic Place Names Committee to say that they'd named a glacier after me, which was rather pleasing in recognition of my polar research. So that was very nice. And so I've got this little pet glacier that I try to keep an eye on every now and then. As soon as I saw my first glacier in 1960, when I was 20 years old, on our first expedition, I found glaciers to be very exciting, interesting things to work on, because they're sort of alive, but they're not sort of alive, if you see what I mean. When you've worked on a glacier and experienced it, it makes noises. It creaks and it groans and it squeaks and it makes some very strange noises. Echoey noises, sometimes related to meltwater inside the glacier, and sometimes simply to the movement of crevasses and movement on the bed. So it's a dynamic environment, even though we're dealing with something completely inanimate. So it's a fascinating field to work in, and I've been very interested in that right from the very beginning. And so glacial geomorphology and trying to work out the effects of glaciers on the land is something that I've been obsessed with continuously since I started academic life, really.
At what point did you become aware of the link between Stonehenge and glaciers? And were you inspired by anyone else's work, or did this sort of happen quite naturally?
I've been interested in Stonehenge ever since I was at school. I had three uncles living in the vicinity of Stonehenge, one in Scrutiny and another one in Pewsey and another one in Amesbury. All involved in the milk business. But anyway, I used to go and visit Stonehenge when we used to go and visit them, and I thought this is all rather fascinating. But while I was at school still, there was a lot of debate going on about Stonehenge and about the bluestones in particular. So I've always been rather intrigued by those. And then my interest was, I suppose, encouraged even more in this very famous program in which Geoffrey Kellaway, the geologist, was interrogated by the great and the good of British archaeology.
Professor Atkinson, do you think that Mr. Kellaway is talking nonsense?
You know, Mortimer Wheeler and Richard Atkinson and Glyn Daniel, I think, was there. Magnus Magnusson was in the chair. And Geoffrey Kellaway, who's a very, very competent geologist, was roasted by these guys. And it struck me as this is the establishment versus science. I was appalled by the arrogant way in which Geoffrey Kellaway was treated by these guys. And I thought, this isn't really very sensible. And as far as I could see, Geoffrey Kellaway was, who wrote a very famous paper on Stonehenge and the Bluestones in 1970, I think it was. He was an honest scientist trying to work out what he saw as being an earth science problem. In other words, how did the bluestones get from A to B? And he was trying to apply his own research knowledge and his own experience in the field to give the simplest possible an explanation. And he wasn't going to be bullied around by senior archaeologists to believing in the human transport theory just because they believed in it. And so I was struck then by the, if you like, the mismatch. And they, of course, had the weight of the establishment behind them, these senior academics, and Geoffrey Kellaway was just a lowly working geologist working for his living, working for the Geological Survey. So since then, I think it encouraged me to to believe that there are two sides to every story, and that really the side which is linked very tightly into the earth sciences is just as important, if not more important, than the one that gets all the publicity, which is the establishment narrative of the bluestones having been carried by human beings.
In our last video, I mentioned that the first book that I read about glaciation was your Bluestone Enigma, published in 2008. What led up to that book?
Yeah, I mean, I'm sometimes portrayed as the the Lone Ranger, more or less. The only person who's interested in glacial transport of stones, and that's way wide of the truth. I mean, when I wrote that book, it wasn't new at all. I mentioned Geoffrey Kellaway, but there was a very big project in the late 1980s run by the Open University, a group from the Open University, a large team of people looking in great detail at the bluestones and their provenances and so on. They were mostly geologists trying to work out where the stones had come from, but inevitably they got dragged into the debate about how the stones had actually travelled, and they were quite interested in looking at how sound this theory of Herbert Thomas was that was published in 1923. And so they looked at that in a great deal of depth, and they came down very solidly on the side of the glacial transport theory. And a lot of other people have published things over the years. So there are scores of people who have made these points very similar to the points I was making in the book. So I looked on the book as drawing together this material from a wide variety of different sources and simply restating something that I thought should be heard by other people from other disciplines, maybe.
People in the comments have mentioned that for some people it's the first time they've heard of it. Mm-hmm. Why do you think it hasn't been covered as much as the other topic?
People love stories of heroic deeds, don't they? I mean, and people love stories about heroic ancestors and lost wisdom and all that sort of stuff. If you look at the amount of space devoted to these ideas of incredibly clever ancestors and things like that, much cleverer than we realise, and so on, that is a very appealing narrative. And of course, when Herbert Thomas came along in 1923 and initiated this story about the human transport of the bluestones, which nobody much had taken at all seriously before that, suddenly there was a narrative that people could latch onto, and they thought this was absolutely wonderful. And of course, the interesting thing about that narrative was that it came out of the blue, really, following the First World War, at a time of great national trauma, where people needed to have their faith in civilization, the triumph of civilization. They needed to have that reaffirmed somehow or other. And along comes Herbert Thomas and tells them about their wonderful heroic ancestors. And nobody questioned him very much. It was extraordinary. Even though nearly all his peers who were working in the same sort of field as him were talking about glacial transport many years before he appeared on the scene.
Could you just briefly describe the glacial transport theory?
Yes. I mean, we know that ice picks up stones and dumps them. Western and northern Britain is covered in glacial deposits and glacial erratics all over the place. But their distribution is very, very patchy. We can get quite wide areas, for example, with virtually no glacial deposits. And then in the past, people have assumed that these areas are unglaciated. This was the case with Buchan in Scotland, for example, where people thought for a long time that the ice had never affected that area. So we've known for a very long time that there are glacial erratics dotted around all the coasts of the Bristol Channel. And gradually a picture has been emerging of a very big glacier which flowed down the Irish Sea, across Cardigan Bay, through St George's Channel, across Pembrokeshire, and up the Bristol Channel. And the question has always been, how far did it get? Did the ice ever reach as far as Stonehenge? Bit by bit, the evidence has been emerging of ice actually reaching quite high up the Bristol Channel, affecting the coasts of Somerset and Avon, into the Somerset levels. And then the question is, how much further did it get than that? Did it actually reach Stonehenge? And I think that's still open for debate, really, and future research. I think it almost certainly must have reached Glastonbury, Westbury Hill, that sort of area. Whether it flowed over onto Salisbury Plain is still a matter of debate, but the models are getting more and more sophisticated all the time, gradually improving the database, the parameters that are fed into the models. And they suggest very clearly to me that it's perfectly feasible that ice could have entrained the stones in Pembrokeshire, transported them up the Bristol Channel and dumped them not very far from Stonehenge.
What sort of evidence for glaciation around the Preseli Hills? And is there anything that the average Stonehenge Bluestone tourist can look out for when they're walking around the Preseli Hills?
Yeah, I mean, this is what my thesis was on, really. So I spent 3 wonderful years hoofing around. There are features everywhere. There are moraines, discernible moraines, big accumulations of boulders in this area, just up the road in Kilgwyn, and various other places around the edges of the Preselis. But most of the landscape doesn't have big moraines. They're quite rare, because a moraine is only built where an ice edge parks itself for a longish period of time. Most of the landscape is covered with till, which is your standard glacial deposit. It's unsorted sediment, quite clay-rich generally, with a large unsorted, and it means it's holding a lot of stones of different shapes and sizes and lithologies. You may get dolerite and rhyolite and sandstone and mudstone and shale and limestone even in South Pembrokeshire. And so these deposits are very widespread, and that's what most of my thesis was about, actually, was the sediments. There are only a few glacial erosional features. The biggest one is probably the Gwaun Valley itself, which is, that's a meltwater feature, but related to the Ice Age. And then Craig y Cwm up on the top of Preseli. It's a lovely little arm-shaped hollow, a bit like the Cwms of North Wales or the Corries of Scotland. And I think that represents a small glacier, possibly before and after the main glaciation of this area. But on a detailed scale, if you look at the tors like Carn Goedog and Carn Alw and Garan Fawr, there's tors all over the place on the Preselis and on Carn Ingley and on Dinas Mountain. They all contain glaciated slabs which have clearly been smoothed by ice, and in some places you can see streamlined features where the ice has been moulded. The bedrock has been moulded by flowing ice. And so there are lots of these little features around, almost all over the uplands, and especially on the craggy outcrops where they occur.
And so, same sort of question, but closer to Stonehenge. What sort of evidence do you point at?
There are not many glacial features, discernible glacial features in the southwest of England. I'm perfectly happy to admit that. What we've got is evidence that's very, very subtle, and the people who've studied the glacial sediments in the southwest of England have identified till, glacial deposits. They've identified sands and gravels, which are meltwater deposits laid down by the melting of the ice. And there are a few subtle features on Dartmoor and Exmoor which seem to suggest the presence of local ice caps. And there is some debate about the features on the Mendips as well. I'm quite sympathetic to the view that some of the gorge features on the Mendips might well be related to very large volumes of meltwater following the melting of a small ice cap on the Mendips. But I think it's perfectly feasible that all of the upland areas of the southwest at some stage have held unique small ice caps, which were then incorporated into a large snowfield covering the whole landscape, really, during the onset of each glacial episode, and then followed by an incursion of active ice from the Bristol Channel area into the Somerset levels from the west, or flowing more southeast actually into the Somerset levels, and then, hitting up against the chalk scarp a little bit further to the east. So they're very subtle features, and I just wish that we could get some bright young PhD students to actually get over there and look at this evidence in detail, and especially, if possible, to get permission to work inside the firing ranges on Salisbury Plain.
The glacial process we and our viewers seem to be most familiar with is bulldozing, and it has a fairly basic description of when rocks and debris found in front of a glacier are pushed along by the moving ice. We then imagine finding a great big line or pile of stones along the glacier's predicted edge.
Yeah.
So have we seen this anywhere in between the Preselles and Stonehenge? And if we haven't, could you explain why?
Yeah, push moraines are not exactly a myth, but they're very rare. I mean, they do occur where there is actually a slightly bulldozing effect. And sometimes you can get ice close to the snout of a glacier, gets clogged with debris and acts as a barrier. And sometimes if there's a re-advance in the ice, it will shear against this barrier and will slide up over the top of it. In those cases, you can get push moraines. I can think of a famous example on Axel Heiberg Island in Canada, but they're very rare, these features. So in general, I think we should say that push moraines are not worth thinking about too much because they're so rare in nature. Lionel Jackson and I did a paper on trying to explain the similarities between the European situation and what's happened in North America. The idea that erratics can sometimes be carried along a junction between two ice streams and sort of concentrated along this junction. And in some cases, you do get a line of erratics all the way along. And that may be the case in the case of Stonehenge and the glacial deposition of erratics. But the problem is that nearly all of this route is under the Bristol Channel on the sea floor, and so it's actually rather difficult to examine it and to find out what's there. So the answer is these features are very subtle, and I think they are very subtle simply because of the time that's elapsed. They're not from the last glaciation. I'm pretty sure of that. I think the glaciation we're talking about is possibly several 100,000 years ago, a long time ago, which means that the glacial deposits are very unlikely to have survived intact over that period of time with solifluction and rain and winds and storms and a huge number of changes of climate, all of which will have contributed towards these deposits being destroyed. If you look at the edges of glaciers today, you can go along fairly sizable chunks of the Greenland ice sheet edge, for example, and there's nothing there. No moraines. The ice is reasonably clean. Here and there you might find some erratics and boulders in the ice and a few little patches of till. But it all depends what the ice is carrying, what the glaciological conditions are. And so we shouldn't expect to find a magical moraine anywhere, I don't think.
The thing I found hardest to visualise when I was trying to get my head around glacial transport theory was how the ice can carry stones east, up and over hills and valleys, essentially ignoring the shape of the land. So could you describe this process?
Yeah, okay. One of the key things to remember is that ice doesn't necessarily have a problem in flowing uphill. It happens all the time, and that the evidence is everywhere to be found because you find that glacial erratics and so on are scattered across the landscape, uphill and down dale really. It's regardless of the shape of the land. And we know, for example, that in fjords, ice flows uphill for 1,000 meters or so of vertical distance occasionally, over a distance of maybe 10 or 20 miles. And we know that, for example, in North Wales, the famous place called Moel Tryfan, where at 400 meters above sea level, there are all these shells in the glacial deposits that it must have come from the floor of the Irish Sea. So there the ice has simply flown up over the North Wales coast, rising up towards Snowdonia. So ice generally will flow in the direction of maximum surface gradient. That's the rule. And so if you can work out where the surface gradient has been, that is the way the ice will flow. And it doesn't really matter whether there are any hills and valleys in the way. It'll simply keep on flowing along in the direction of the surface gradient. It makes sense as long as you can find evidence that the ice surface has been higher and higher and higher the further back you go up the glacier. And eventually you'll skid to a halt, because that's the point at which the ice surface was at its highest, and that's called the ice shed, the point from which the ice has flowed. Ice will flow in valleys in a mountainous environment if the ice is coming from the mountains themselves. And so in those circumstances, as in the Alps, for example, and indeed in Snowdonia to start with, and in northern Scotland, in the early phases of a glacial episode, the ice will flow in the valleys because the ice is coming from the mountains. Essentially what happens when an ice sheet is building up, when you've got a major cooling of climate going on, and the climatic cooling is resulting in more and more extensive snow cover, more and more precipitation of snow itself, more and more of the landscape affected by glaciation. You'll start off with local ice caps on the uplands, and eventually they coalesce and the ice sheet just keeps on growing, and eventually the mountain centres that were there to start with, they simply get overridden and overwhelmed by the ice flowing from the ice sheet. And once the ice sheet has established its working position, shall we say, from that point on, the ice flow directions will be determined by the surface gradient of the ice sheet. If you've got something that is constraining ice flow, such as a fjord or a big river valley, and the ice is all coming from the mountains at the head of the valley, for example, it will flow in the valley, and it'll make that valley deeper and deeper and deeper. And so it will transform a nice gentle river valley, for example, with a nice gentle cross profile. It'll transform that into something seriously spectacular, like Sognefjord or Hardangerfjord, or some of the other big fjords, the fjords in Greenland, Nordvestfjord, which is the one I was working in. So what will happen is that these old valleys will simply get deepened and deepened. But as soon as the ice sheet takes over, as soon as the interfluves are covered by ice, everything just gets amalgamated. And from that point on, you can find the ice flowing diagonally across a fjord, for example, and the fjord will have no effect whatsoever on the direction of ice movement. And that gets seriously weird. And if you look at Greenland now, there are many examples of a fjord landscape which is completely chaotic, where sometimes the ice is flowing in at one phase of a glaciation in north to south, and in another phase of the glaciation it'll be flowing south to north, depending on exactly where the ice center was and on the shifts in the dynamics of the ice sheet itself.
We have the latest claims regarding the possible Scottish provenance of the Alterstone. My first question is, do you think glaciers could have brought that rock type from the north of Scotland to Stonehenge landscape?
I won't use the word impossible, because I don't like that particular word. It gets used a bit too often, I think. But I think it's highly unlikely that ice will have carried a stone all the way from the Orkneys, for example, if that's where it has genuinely come from, all the way down to either West Wales or the Stonehenge area. Simply because from what we know of the directions of ice movement over Orkney, the ice was influenced in part by the Scandinavian ice sheet. The Scandinavian ice it certainly hit the edges of Shetland, and it also had an effect on Orkney as well. But the ice seems to have been moving across Orkney from the southeast towards the northwest. Now, in those circumstances, it would be very difficult to imagine a situation in which a big erratic like the Alterstone could have been carried by ice all the way to Stonehenge. So I would agree with the authors in that particular respect, and share their scepticism about the possibility of ice transport all the way from the Orkneys to Stonehenge.
But as you clarified, you're cautious of saying the word impossible, and I have seen a couple of things that we're talking about. Potentially it could have gone northwest and then coming south. So when you say it's not impossible...
We only know a lot about the last glaciation.
Okay, yeah.
So we know a lot about what happened in the Devonian about 23,000 years ago. So that glaciation is well known. So that's what I'm talking about when I say the ice, as far as we know, was moving from the southeast towards the northwest. We don't know very much about what happened earlier, and that's where the next interesting set of work is going to come, because the modelers who are currently, like the people who've been working on this big Brit Ice project, for example, they've created a fantastic model now showing how the Devonian ice expanded out and out and out, how its flow directions changed from one time period to another, and they've shown where all the big ice streams were. So that's pretty well known now. I think we can assume that in early glaciations, it won't have been that different from the Devonian, but there may have been shifts in ice shed positions that we don't know about, because these old changes of ice direction are very difficult to discern in the landscape, because the Devonian glaciation, glaciations are very destructive. They destroy the evidence of their predecessors. That's the problem. But we do occasionally get clues, such as finding ancient glacial deposits in places where we don't expect them. And I found 5 or 6 locations in Pembrokeshire now where I think we're talking about extremely old glacial tills that have never been described in the literature before. There are stones that are where the origins are not really known properly, but yes, certainly some people do think these are Scottish erratics, and certainly some of the known erratics on the coast of Devon have certainly come from Scotland. Nobody much seems to dispute that. So we know that Scottish erratics have been carried a very long distance, some of them ending up on the shores of the Bristol Channel. But I'm a bit dubious about whether the previous glaciations were that different from the last one. But as I said, not impossible.
If you believe that the action of ice is unlikely to have delivered that stone from Scotland, what other alternatives are there? And is human transport the only other option?
No, I don't think so. I think at the moment, from my reading of the article and from the geologists that I've spoken to, I've been in touch with a number of people who are specialists in the old red sandstone and who know rather a lot about this. Their main concerns and my main concern are to do with the reliability of the conclusions that have been drawn by the authors, given the extremely limited sampling base or database that they've got, where they've only got 2 samples, for example, that they've examined, supposedly from the altar stone, but we don't know that they're from the altar stone because they're from rock fragments that were found in ancient collections with bits of paper stuck onto them, saying this is a piece of the altar stone. That's not a very good basis for scientific study, and I'm very dubious about the use of surrogate samples of this type, which can simply be assumed to have come from the place where we think they've come from. And I'm very concerned that the geologists involved in this project didn't insist on going to English Heritage and saying we must have a sample from the altar stone. They should have gone straight to English Heritage and said we've got hugely important research here. We're about to make a suggestion that is, completely crazy according to the conventional wisdom. But we think we're sound. We think the science is sound, but we must validate the research by having a sample from the altar stone itself. And in not doing that, I think they've spoiled their own research in a sense and created a degree of skepticism that they could have done without, probably.
This piece of rock was taken from the underside of the altar stone in 1844, and with permission we've been able to take a small piece off to make a thin section, and it's that piece that went down to Australia to be analysed and dated.
I think they've been very foolish to leap to this wild conclusion of the altar stone having come from Orcadia, from either the Orkneys or from Caithness, on the basis of just 2 samples of stone, which may or may not have come from the altar stone. And I got a message today from a guy that said if in my field of study, he said if someone had tried this sort of stunt, they would have been prosecuted because to come to such a huge conclusion on the basis of such thin evidence, and with this added complication of the surrogate samples having been used, he said you'd be laughed out of court, really. And so they've got 2 altar stone samples, 2 samples from Orkney and from Caithness, and this is the whole basis of the article. The rest of the work is based upon investigations of the zircons and some of the other heavy minerals in other parts of the old red sandstone domain, the places where old red sandstone is outcropping in the British Isles. And what they've said is that look, the matching between the 2 samples from the altar stone, so-called, and the samples from Orkney and Caithness, the matching is very, very good. And statistically sound, because we've done all sort of probability studies and all that sort of stuff on them, and we find that the conclusions stand up under scrutiny. And then the other areas that they've investigated, those areas are already in the literature, and the concerns I've got about some of those are that they've chosen the best possible match, of course, for the association that they want to demonstrate. But as far as all the other ones are concerned, it seems to me that they've done some cherry picking, and that they've chosen the samples from the literature that show the greatest divergence away from the samples, the 4 samples that they're putting all this emphasis on. And I await the advice of some of the old red sandstone specialists on this, because I'm already a bit concerned about the fact that the sample from the Midland Valley, for example, that they mention, which comes from a Silurian outcrop of sandstone, which is grouped into the old red sandstone group, which means that you've got a massive amount of sandstones in the Midland Valley, over thousands of square kilometres, with several kilometres thickness of deposits, which are completely unrepresented in this data. So what they're doing is they're assuming that the sample that they're citing in this article is representative of the old red sandstones of the Midland Basin, which is far from the truth. And so I'm worried about that, and I think other geologists are as well. And I expect the detailed scrutiny of this article to be based on exactly that point, is how representative are these samples that are used in the paper of the nature of the old red sandstone signatures that they are putting so much emphasis on.
So just to clarify, in theory, you could take 2 samples from Welsh red sandstone, and under this scenario, they could present very, very different signatures, depending on where they were taken from.
Yeah.
In the basin.
Yeah. Yes. And we know already that even with the altar stone, for example, there's been a lot of X-ray work done on the altar stone now. There's huge differences as you scan across the surface of the altar stone. There's not very much visible. I mean, just a little patch of bare rock. And if you take X-ray readings from across that, there's a massive amount of difference as you go from A to B, just across a single piece of stone. So when you multiply that up 1,000,000 times and you say, what range of variation is there within the old red sandstone sequence of the Midland Valley or anywhere else in Britain, or even if you talk about the South Wales old red sandstone outcrops, which the geologists have already looked at, there's a huge variation within that area. And so how wise is it to assume that the sample or the little group of samples that you're looking at is really representative of that vast area of territory and that vast thickness of rock? And that's what worries me about this, that they're making a gigantic leap of faith in attributing significance to these samples that they use in some of the diagrams in the article. And I'm absolutely sure that the geologists will go after this quite enthusiastically, by the sound of it, from what I'm picking up.
So for you to have a bit more faith in an announcement that claims a Scottish provenance for the altar stone, what would you need to see? You'd need to see more sampling, some actual samples of the stone, and you'd need to see more sampling both in Wales and in Scotland to compare the results.
Yes, I think that it would need an enormous sampling exercise. I mean, doing these tests is not cheap. Measuring, the zircon granules or grains, very small mineral grains, but to measure those is a massive exercise and a very costly one. And so that's why, obviously, not many studies of this type have been done before. But I suspect that, as a number of people have said to me, extraordinary claims require extraordinary evidence. And this is Carl Sagan who said this many years ago, of course. And they're saying this is such an extraordinary way out claim that these guys are making, that they really should have been much more careful in ensuring that the weight of evidence was worthy of the claim that they're making. And in fact, one of the referees of the paper said exactly this. And it's there for anybody to see if they want to check what the referee's comments were. And he said, you're making such an extraordinary claim here that you've really got to be much more certain about, the strength of your evidence if you're going to expect anybody to believe it. And my skepticism is really to do with that they should have been much more critical about the likelihood of their claim about long-distance megalith transport actually being supportable. And I think they've also been rather naughty in pretending that the long-distance human transport of stones is already established by previous papers about the bluestones. Now, I dispute that, and I think they've been rather mischievous in this article in pretending that human transport thesis is not disputed, because it is disputed by me for a start, and by a lot of people, other people as well, and they should have been more honest about that.
So it's the same sort of question again, but a little bit broader, is what sort of evidence in general would be needed to convince a skeptic about human transport now? So sticking with the human transport.
Well, a sledge with a big stone on it on the bottom of the Bristol Channel would be nice, or something like that. From a technical point of view, I'm extremely sceptical about the human transport theory because, I don't think they had adequate ropes, of adequate quantity to, they might have been able to build sledges reasonably well, but we're talking here about a major logistic or technical exercise. And so maybe a raft or a curragh or something, and remains of it in the mud of the Gwent levels or something would be very nice, or some hard evidence. But I think the thing that I'm most concerned about is the fact that there is no evidence, as far as I can see, of the development of a long-distance transport technology and then the decline of that technology. For example, the introduction of metal smelting, or the evolution of stoneworking techniques with respect to weapons and tools and things like that. It starts off pretty crude, it gets more and more sophisticated as time goes on, and you end up with these beautiful Bronze Age stone artifacts, which are absolutely fantastic and wonderful examples of craftsmanship and art as well, one might say. So you've got a technology that improves, gets better and better, and then it declines, it fades away. But you would expect evidence of that in the record. And as far as I can see, there is nothing to demonstrate that the long distance haulage of stones was thought of by somebody and started by somebody and then developed by other people and got better and better and better until, as a summit of achievement, they haul 80 bluestones from Pembrokeshire to Stonehenge, and then we see the technology declining again. There's nothing of that type at all. And so all of these ideas about innovation and diffusion of technologies have been abandoned by these guys. They've just assumed that out of nowhere you get this fantastic enterprise of long-distance stone haulage without any track record of any sort that we can see in the history of the use of megaliths for building. There's nothing of any sort which will demonstrate that the usual pattern of diffusion and innovation has been followed. And that worries me. I think, if they could come up with something to demonstrate mini Stonehenges, if you like, or mini stone haulage expeditions before and after the crowning achievement of the building of Stonehenge, I'd be rather interested to hear about it.
So then we've just got two left. I think we'll go with this one. So it's essentially the same question, but shoes on the other foot.
Yeah.
In an ideal world, say you had a load of funding and you were back in the field, what sort of evidence would you look for to prove glacial transport for the final time?
Cosmogenic dating of the Stonehenge Bluestones. That's my simple answer.
And what happens is when, say, a boulder slides off the margin of a glacier and lands in a pile of debris, it's then exposed to the sky and to the incoming cosmic radiation from outer space. And these particles associated with cosmic rays come and bombard the atoms that make up quartz in rock. In this instance, they blast apart silicon and oxygen to create something we call beryllium-10. And beryllium-10 builds up in the surface of the rock over time. And now we have the analytical methods in place to take a sample of rock and measure the number of beryllium atoms in that surface. And we can actually derive a precise age of when that boulder first fell off the last glacier.
I've been convinced for quite a long time now that cosmogenic dating is now mature enough to enable a proper research program, properly funded, to establish the ages of the surfaces of the bluestones at Stonehenge. As we all know, the stones at Stonehenge, the bluestones, are mostly boulders. They're erratics of all shapes and sizes. They've got heavily weathered faces, and they've got some faces that aren't so heavily weathered. And they've got what I think are glacial facets, flattish areas that appear to have been the result of glacial abrasion. And then you've got fractures, you've got bits broken off and so on some of the stones. So this is all absolutely amenable to cosmogenic dating. It'll be expensive because on some of the boulders you may have 3 or 4 different faces, all of which need to be dated. But I'm pretty convinced that hardly any of these dates are going to come out at around 5,000 years ago. By differentiating between faces on the Stonehenge bluestones that have been exposed to the atmosphere for possibly hundreds of thousands of years, and other faces that may be fresher, maybe tens of thousands of years or whatever. But I wouldn't mind putting a small bet of a few quid on the fact that we will find virtually no evidence of quarrying on these stones. And I think that their appearance, to me, seems to be suggestive of boulders that have been lying around for a very long time before they were actually collected up and incorporated into the monument at Stonehenge. And I hope that somebody or other can raise £1 million or so to do it, and I hope that English Heritage might agree to it as well. We're going to have a compromise in the end, aren't we? Because when you've got two fairly extreme positions, as we have at the moment, I mean, my view and the view of a lot of other glacial geomorphologists in the past has been that Salisbury Plain might well have been glaciated. It's just that it was so long ago that the evidence has been dispersed and destroyed to a large extent. Although there there are so many little glacial erratics dotted around over Salisbury Plain that really I think it's a very strong chance that we do indeed have glacial deposits, possibly somewhere inside all these firing ranges. If only they could disappear for a while, or we could get permission to go in there and really search properly, I think this issue would be resolved. But I've never disputed that the people who tried to build Stonehenge were pretty ambitious people and very imaginative with a their aspirations were phenomenal. No doubt about that. I think eventually we will come to a compromise which says that the ice has carried these stones so far, and that the area in which stones were dumped still has to be determined. And at that point, they were picked up and transported and built into Stonehenge. So human involvement is inevitable at some stage in the story. And I think that the thing that gives me great confidence is that Stonehenge was built from material, or partially built, because I don't think it was ever finished, but partially built from stones in the immediate vicinity. My confidence in that is that that's exactly what's happened everywhere else. I can't think of a single example anywhere in British prehistory of large numbers of stones being transported from a long way off. And the general rule of thumb in one after another British megalithic monument that gets examined is that they simply used what was there. And my theory is not, again, it's not a unique one. Other people have said the same sort of thing, is that Stonehenge was never finished. I think the builders of Stonehenge possibly chose the site because it was conveniently placed with respect to a lot of stones lying around on the surface. And I think they used up as many stones as they could find, both sarsens and bluestones. And they spread further and further away from the site of the building to acquire more and more stones. And eventually, I think they applied perfectly simple cost-benefit analysis and decided that, hang on, chaps, this is just a waste of time now. We're expending so much energy traveling over these great distances to find more stones that at that point they simply gave up on the whole thing. Having messed around with all sorts of different stone settings, everybody knows that happened, that the bluestones and the sarsens have been used over and over again in different stone settings. And I think that's partly a reflection of the fact that they never had enough stones. So that's my theory, but I'm very happy that there should be some sort of compromise eventually, and that's fully what I expect to happen, actually, where, of course, it's not completely black and white. Everything ends up being somewhat grey.